Let's see. Has it started? Yep, it has started. Welcome everyone to today's live stream. I will be teaching you physics and I will be continuing the previous lesson with you. So before we begin, let's have a few quality checks on whether the stream is going correctly or not. So on a scale of 1 to 10, how would you rate the quality of this broadcast? Is my voice clear? Is my video good and crispy? And can you see everything on the screen? Is everything all right? Just type down the number on the chat. Let's see. Let's see. So today I will be doing basically the continuation of the previous lesson, which I did. And let's see if my stream is perfectly working. Then we shall move on, right? Yeah, the trackpad is working, everything is working fine, right? How about this? Maybe this could be 1, 2, 3, 4, 5, 8. Okay, if it's 8, then there's something which might be a problem here. Maybe if I speak a little bit louder, then maybe it could become 10 or not. How about that? Could it work? Let's see. Okay, let's see. How's it going on? So anyways, shall we get started right now? I believe if I speak loudly, maybe it could be considered 10, but let's move on, right? Okay, let's move on then. So let's see, are there any viewers in the chat? So how is your preparation for the exam? Let me see if are you sad that you have not studied correctly, or if there's something wrong that is going on with the preparation? Hello Satyendra, hi, welcome to the stream, and good afternoon, thanks for joining us. So please answer the question. Only I am there, sir. Then that's great, don't worry, some people will join you, your friends will be here soon, don't worry. So how is your preparation going, Satyendra? Are you feeling any stress? Is there anything that you need to talk about or something? Hello, Mihir Chaudhary. Oh, my Mihir Chaudhary, my man with the dab. Welcome to the stream. Raj Chopra, hi. Nice name, by the way, Raj Chopra. I like that name. And how is your preparation going? So, did you study what I taught you in the last class, or how is your preparation going in general? So, what is up with you guys, right? Tell me. Let's see. Are you the sad angry face, or are you the satisfied face, or are you the satisfied and happy face? I believe you should be somewhere here, or I hope so. I am something. Hello. Yep. All right. So if there's anything that you need to talk about in your preparation journey, please let me know. I will be happy to help. And now let's get started, right? So a little bit about me. I'm gonna give you my introduction. So about me, basically, I gave JEE a few years ago, and I received more than 99 percentile in. Okay, I'm gonna start. Don't worry. I received more than 99 percentile in physics and chemistry. So, and I had more than 250 marks. So my interests are in microsystems and UAV, and I'm currently pursuing that. I have also written 2 papers which have been out there for publication. And I will be teaching you physics, my passion actually. So let's move on. So basically, let me give you a quick introduction, just a 2-minute brief of your course. Exams are coming. That's great actually. You know, exams are a great way to practice, to be honest. If you think about it. Don't worry about exams, bro. You're gonna rock it. Don't worry. Exams are just a piece of cake. And I believe they might be somewhat. Let's see. Yeah. I believe they might be somewhat preparatory exam or something like pre-boards or something like that. But don't worry about that. So basically, let me just give you a quick introduction. Our course have 90+ classes, and we also check your homework. We also provide homeworks. And we have convenient education platform. We have syllabus from JEE experts like me, of course, and other 3 faculties from JEE, 2 faculty from JEE, and we have flipped classroom method. I'm going to tell you about that in a little while, and also doubt solving practice. So let's let me tell you what type of material do we have. We have theory classes, then study materials, then webinar, then homework check. So basically you will be provided these things, theory and study material, before the class, which actually you should do, because this method is followed by one of the top universities in the world. That means Harvard, MIT and all that stuff. So they follow this pattern. They provide you with theory and study material beforehand, so that when you come to the class, you come prepared. And when you come prepared, you understand everything which is being taught here. By the way, I also used to study like this only. And when you go out of the class, you do homework, and your homework gets checked. Basically assignments, right? So that's how top Indian universities do that too. Basically IITs, DTU and NIT and all that. But yeah, so they do that too, and that's how our course will look like. So that's this is a subscription plan for a course which has interactive live classes, structured courses in PDF, live tests, physical notes in the live packet, because we understand that not everyone comes from a same financial background, but we would like everyone to have a piece of knowledge. Like, knowledge should be available to all, right? They should not be bound by the financial differences. So that is in the live package, in which you will get live classes. That is basically the most important thing, basically. And in the smart package, you would have one-to-one mentorship, sometimes needed to solve personal issues which are very common in your IIT journey, especially in the 11 to 12, as you all are adolescents. Live doubt solving, of course, it is also necessary when you have doubts, right? That's in that way you will feel like you are talking to an actual teacher. And mock test. Believe me when I say this, mock tests are probably the second most important thing in IIT JEE journey, after classes, or basically after notes. Because if you do not take your test properly, then basically they give you an experience of what's going to happen. So in my first mock test, which I gave in class 11th, right, in my first mock test I received around 118 marks, yeah, out of 360. That's very low. That was pathetic. So I improved that from 118 to 315 in my last mock test. So that's what, that is, I'm giving you an idea about what's going to happen if you take mock test, and how the progress changes. How the progress happens, basically. So from 118 to 315, imagine this. So you can also be like that. You can also improve. You can even go to 360. It's 300 now, sorry. But yeah, you can go to the highest marks possible. Nobody's stopping you. So basically, mock test is the way to judge yourself and to improve upon that. Keep that in mind. And in professional package, if you're looking for an extra edge, then you will have additional special courses in which you will have additional content for you to study. But the smart package is probably the best work for money. But if you want to add an extra edge, then go for professional. So let's move on and let's start today's class, that is gravitation. Oh, I will try to speak more slowly here. All right, I will try to speak slowly. Don't worry. I want to tell you all these things in so much little time that I sometimes speak too fast. So that's why I sometimes speak too fast. Yeah, I will speak a little bit slowly to you. Don't worry. So let's get started, right? So this is our second lesson in our chapter Gravitation, one of the most important chapter and one of my favorite. So let's begin. So let's talk about gravitational potential energy. Let's start where we left off. That means we left off at variation of gravity with latitude. Now we're gonna talk about gravitational potential energy. Don't worry. So this is a very interesting topic. Right, so it's all about definition and derivation, basically. So what is let's see. Let me just have my notes here with me, so that I teach you everything which I have in my mind. Right. So what is potential energy? By the standard definition and by the standard formula, potential definition would be, let me write it down here. Okay. Let me just write U equals integration of minus F dot dr. right? And R so this is from reference point to R. That is called U. Should I write it in black? I believe I should write it in black, because that way it will be more in a more clear sense. So let me just use equal sign and write it in black. Where's in color? Yeah, so basically in black color this will be like R reference to R minus F dot dr. This would be like this. All right, so this is your formula for potential energy. Now this is the formula, right? So we do not study by formula, right? We study by definition and understanding what it is. So basically, what do we mean by potential energy? So basically it is the energy required, basically it is the work done to take an object from R reference to infinity, right? So that is what our energy is, or basically you can say that to bring I mean, how much energy does an object have when it is brought from infinity to a reference point. That means how much energy does it have now. So basically that is the gravitational potential energy, or the change in energy, because at infinity it would have how much energy? Zero energy, right? Because it is not being influenced by anything. But when we bring it back to a reference point, when it is influenced by gravity, then how much energy would it have? So that is our gravitational potential energy. So basically the change in energy when we bring a particle from infinity to a reference point, right? So let's just write it that way. So it is change in energy, and oh god, let me just erase this. Change in energy when we bring a particle yeah, I've written it correctly, I believe. Okay, particle, yeah, particle. When we bring a particle from infinity to a reference point, right? Infinity to a reference point. Yep. I'll write that down. Infinity to a reference. Oh, I believe I should improve my handwriting, right? I'm thinking about it. Don't worry. To a reference point, right? So it is basically the change in energy when we bring a particle from infinity to a reference point. So what would be the integral? What would be the upper limit and lower limit of the integral? So basically lower limit would be infinity, upper limit would be R. Suppose we are bringing an object from infinity to R. So let me just write it down. And what would be, and then of course F dot dr, again minus sign, again would be equal to change in energy from infinity to bring to that reference point. So U infinity minus UR. Please write this down. This thing will be very necessary, because you need to understand how it is derived. Even I sometimes get confused when I think about what is happening in this gravitational potential energy. Infinity to R. Okay, thanks Sabine for 200 subs actually, but yeah, infinity to R, yes, exactly. So please write this down, because what is happening is change, like exactly what I said, when we bring in a particle from infinity to a reference point. That is what happening, reference point being R, right? So something like this is happening. Suppose we have this earth over here, right? It has like various continents, right? Maybe something like this, and then yeah, you understand, right? This is Earth. So suppose we bring an object from infinity. This object is over here, like at infinite distance, at infinity basically. So it is not being influenced by Earth at any moment at all basically. So we bring it towards a distance r. Suppose the distance is r. We bring it over here, right? So now what would be the change in energy? That is our gravitational potential energy. Because let me why do we not say that change in gravitational potential energy? Because it will become quite apparent. Why? Because at u infinity, so let me just write it down again, with the value of f being g m m small m by r square, that is f, right? So f being that, so let's see, minus u r u infinity equals minus f, sorry, what is f, g m m upon r square dr infinity to r, right? So keep this in mind. Now this is the final equation which I think is necessary for you, because everything which is gonna happen after this is derived from this. If you understand what is this, then you have nothing to worry about. So now u infinity will be 0. Why? Because if it is not being influenced by anything, that means if this particle is not being influenced by anything, that it would have no energy at all. Let me just drink water. Sorry, my throat is a little bit sore. Yeah, okay, so yeah, it would be 0 because it is not being influenced by anything at all, and it has no energy. It is not moving, it was not moving. First of all, the first point, it was not moving, that means it has no kinetic energy, and it has no gravitational energy too, because it was not being influenced by any force at all, right? That is what we mean. So it will be 0. That is what we have taken it to be. You can assume it to be 0 too, that will also work. So let's write down another thing. So this will be minus ur equals minus infinity minus minus integral of infinity to r g m m. So this will be basically constant, we don't have to worry about that, up dr by r square. So this is the thing which we have to worry about, right? So let me just write it down like this. How about I don't do that, how about I do this? Yup, r square infinity to r, right? And this minus minus will cancel each other, so let's just remove that too, right? So we have everything removed. Now we're gonna proceed further and talk about what's happening over here. So this is the last equation. U r shall be equal to, let me remove this earth. By the way, you must have written this definition, so I'm gonna remove it because I need space, a little bit space to work. Sorry, my earth. I'm gonna erase you. All right. So this is change in potential energy. Okay, let me just write it down up above, because that is a better way. So that means potential energy at a reference point shall be equal to gm small m. So this will be minus 1 minus r, 1 minus 1 by r, from infinity to r. Again, as you said, infinity to r. This will be like that. Yeah. So what is this? Let's talk about this. What is this? So this will come out to be, let's open the limits, the gmm, 1 minus 1 by r minus 1 by infinity. Okay, I made that in 8. I'm gonna erase that 8 too. So infinity lying down 8, yeah, basically the same thing. Not the same thing in maths, but you understand my point, right? So this will be like this. So this thing will be 0. So what do we have as potential energy at reference? That would be G m small m upon r, but not only this, minus, again writing it down in a better way, so that it is more understandable and more beautiful to look at. Basically, there's a beauty in physics. If you think about it, everything works so perfectly as if it is created by an intelligent being, right? Yep. All right, we have minus g mm by r. Yep. Now, think about this. How is this minus? Why is this minus sign here? That means, how can energy be negative? How can energy be negative? So let me just tell you one thing for a fact. That means energy of a binded system, energy of a system that is binded to someone, energy of some system that is suppose in a, yeah, basically binding, that is the correct word. So I'm looking for another word, but yeah, which is binded is basically negative. Energy of this thing will be negative, and the energy of that electron in an atom will also be negative. In an atom, of course, not a free electron, but in an atom it will be negative. Why? Because it is in a binded system. That is why. Now it will have a kinetic energy which will be positive, and that kinetic energy will be around half of it, positive and half of it. I'm gonna give you the relation of what is the relation between kinetic energy, potential energy, and total energy. Basically, total energy is nothing but Ke plus Pe, sum of kinetic energy and potential energy. So this thing is very important to understand everything. Basically, gravity, electrostatics, the structure of atoms. So this concept will tell you why the potential energy, why the total energy of a binded system is negative. That's why it's binded, right? Because at infinity it was at 0, right? And everything wants to lose its energy. Like every object in this nature, in this universe, wants to lose its energy. So they want to lose their energy to something. How will they lose their energy? So they are thinking about that. How can I go beyond 0, right? Well, actually, so they go in a binded system. So we are taking this infinity to be 0. It may or may not be 0, but our energy at reference point will be less than the energy at infinity. That means it has lost some energy to be binded. That means it wants to be binded. That's why I said that. That's why you can say that gravity is an attractive force. Because if it is attractive force, that means it will bind objects, and objects will lose their energy, and that will work perfectly, because you cannot give the object energy and then bind them. That sounds somewhat difficult to do that, right? Somewhat illogical, to be honest. But yeah, they have lost their energy and become binded. Same thing with it goes in electrostatics. Same thing happens in the structure of atom. If you understand this fact, then everything will be perfect for you in this chapter. Don't worry. So now let's move on to next topic, which will be our escape velocity. Enough about gravitational potential energy, but that was an important topic. So before we move on, let me just drink a sip of water. Yeah, let's do this. So what is escape velocity? Escape velocity is the velocity that is sufficient for a body to escape from a gravitational center of attraction without undergoing any further acceleration, right? So basically it is the velocity that you would need to throw an object upwards so that it would escape Earth, or basically any other object. But yeah, it's that. So this image is wrong. Basically it's kilometer per second. Oh my god, that is not the correct thing. Yeah, it is kilometer per second. Yeah, so it comes out to 11.2 kilometer per second. Spoiler alert, right? So nothing to worry about there. Oh God. Yeah, I lost my marker because that was of color white, right? That's amazing. Yeah, in color black. Yeah. Okay. So it is a velocity. Okay. So let me just write down the how it is derived, write down the derivation. So basically you throw an object in the air, that means the ke lost by mass m again. So it's like loss in K equals gain in PE. That means loss in kinetic energy is equal to gain in potential energy. Energy cannot be lost and cannot be destroyed. It can only be transferred from one form to another. That is what we always say, and that is the law of conservation of energy. You should remember that. So basically, Ke lost by mass m, suppose we threw an object with mass m, shall be equal to Ke, sorry, of course not Ke, but Pe, potential energy, right? Yep, potential energy. Potential of, why am I writing? So let's write it, don't worry. Potential energy, yeah. Ke lost by potential energy. I shouldn't have written the full thing, but anyways, let's go. Potential energy gained by mass m. P, yeah, exactly. P. That's what I was going to write, but then I don't know why I wrote the whole thing because it was in my mind. But anyways, so Ke lost by m is equal to P gained by m. Nothing to worry about. Everything is fine. So what would be Ke lost by m? Half m ve square. That means you threw an object, suppose the object lost, suppose the object has lost complete, suppose an object has completely lost all of its velocity, all of its energy, and then it has gained some potential energy basically, right? So how would an object lose all of its energy? Basically its velocity will become zero. Now when its velocity will become zero, that's what we're talking about. So Ke lost by m, that means half mve square, that was its initial value, minus half m 0 square, right? So I don't, this is for explanation, I don't think I need to write it, so I'm gonna remove it, but oh, why not, let it be, what harm can it do, is equal to gp final minus gp initial, basically, yeah. What will be good? Gravitational potential energy final minus gpe I. Yeah, that would be your GP final minus GP initial. So write this down every time that it is final minus initial, because sometimes you're gonna forget it. Like it will be GM by what? Infinity, right? Infinity minus, because there are minus signs involved, right? That's why I'm saying that you should write down everything in order. Minus gmm by r, suppose we are throwing it from the surface of earth, right? Minus gmm by r. So this thing, first of all, this thing will be of course zero, this thing will be zero. So what would we have left would be half m ve square, that will be equal to gmm by r. Again, cancel it out. So from here we have, I don't think I should write that. Okay, from here we have ve equals root 2 gm by r. That is your velocity of escape. This is a something trivial, which is sometimes asked in trivial questions. That's why I'm telling you this. You should not worry about this that much, because this will be too much understood for you. Like you will understand this too much by the end of your gravitation chapter, after you do some questions. Basically do 10 questions on this, no, yeah, 10 questions on this, then you will be perfect, right? So this is ve, and it can also be written as root 2 gr, right? So the value comes out to be basically 11.2 kilometer per second. So that was a spoiler, and let me remove something like this, so that I would have something to, so I would have some place to write it on. By the way, I cannot delete Earth sadly in this scenario. I wish I could, but no. But yeah, so VE shall come out to be 11.2 kilometer per second, right? That is your VE. This is the value of VE basically, because everything is constant. G is constant, R is constant. So this is the velocity of escape from Earth. This is the formula. Formula is necessary because sometimes they will say that suppose if the radius of the Earth has doubled, what will happen then? Suppose if the radius of the Earth has quadrupled or divided by 4, or if Earth has shrunk by this size, what will happen to the velocity of escape? Then this thing would be necessary to comprehend. Let me just drink the water, and let's move on to the next topic before we do this. Yeah, so this topic is pretty interesting because the questions from this are very somewhat typical, as you might have seen before, but sometimes they can be wrong. So keep this in mind, that doing this doing as many numericals as possible will only help you, and nothing's gonna go wrong if you practice more. Let's move on to the next question, next topic. And before we do that, let me just tell you, there's a Telegram group in which we get all the updates and PDF materials. There are updates of free classes, and there are various announcements. There's of course discount and prices, and of course a giveaway is going on, that 10 random people from Telegram will be chosen to give a will be given a 1 month of free course on our website. But that, because of course that would help various students to pursue their IIT JEE goals further. And please join the Telegram if you are interested in that, because there are free classes too, like which happens regularly. So let's move on to the next topic, which will be orbital velocity. So orbital velocity. Though this is the thing which says that how much velocity a satellite needs to have so that it could orbit. Basically, it could revolve around the center of the Earth, right? So how much velocity would it need to have so that it does not fall? So you can write a definition. Basically, definition is nothing. The definition is the velocity of a satellite in the orbit is orbit velocity. But let's write down a definition which is more worthy, so that velocity which a satellite needs to have, which a satellite needs to have so that it does not fall. It does not fall, right? So why will it fall? Let's talk about this. Why will it fall? Because the Earth is attracting it towards itself, right? That's the main reason. So there's a force, gravitational force, which is being applied downwards, right? There's a gravitational force which is being applied downwards. Suppose this is a satellite. Let me just make this. This is the gravitational force that will be applied downwards. That is Fg, right? And there is another force which will try to balance it, and that force is called centrifugal force. So Fc. So centrifugal means away from center. So centrifugal force, centrifugal or centrifugal, whatever you like to call it. So basically the definition is like this, the spelling is like this: centrifugal, right? So this force will be applied against gravity, right? This is the basically remember when you mix something in the mixer grinder or something like that. So every object goes towards outside, right? Every object just rushes towards outside. Why does it happen? Because they are being subjected to centrifugal force, right? And there is also another force called centripetal force, right, which is of course earth gravity. Centripetal force, centripetal force, petal force. So this can be any force, but the meaning of this term, the root meaning of this word is called center seeking. So that means it seeks center seeking. So let me add it in block letter, center seeking. So that will be your centripetal force. So if centripetal force seeks center, that means if centripetal force wants center, then centrifugal force would want to get away from it, away from center, right? So this is your basically this is your centrifugal force and centripetal force. Now what is centrifugal force? That is mv square by r. Yeah, r is the distance between the center of the earth and also the satellite. So mv square by r shall be equal to g m small m by r square. Basically this is the formula, basic formula which you need to remember, then everything will be solved. So everything can be derived from this. So what will be the v, what will be the velocity of the satellite? So we can cancel this out. So velocity, okay, velocity will come out to be gm by r. So this will be your velocity of a satellite, orbital velocity, right? Nothing to worry about here, because orbital velocity is basically nothing too different. So if a satellite is too close to earth, that means for satellite close to earth, so what will happen if a satellite is close to earth? That means r becomes near to equal to earth's radius, because small height does not matter that much when we're talking about earth's radius. Earth is very big and its radius is also very big, so a small height does not matter that much. So r will be equal to r, then v shall be gm by r. So again, for satellite close to earth, nothing too far away, nothing too sinister, but something which you should keep in mind. Okay, now let's move on to the next topic, which is our time period. I guess, yep, I was correct. So what is time period? Let me just what is time period? Time period is basically, as you can see from the name, it is basically the time needed for a satellite to revolve around the sun. Suppose the satellite is like this, right? Suppose this is earth, right? Earth small, something like this. Yeah, earth has many perfections. So a satellite is evolving around it. So that means, what is the time period that the satellite would need? So it's a very small thing. So as we know, time period is like the circumference 2 pi r divided by the v. And what is v? V is, as we calculated, orbital velocity is root gm by small r, because r is the distance from the center of the earth to the satellite, that is r, right? So gm by r, so that means t shall be equal to 2 pi r by root gm into r. I just transported this r upwards, right? So let me write it down like that only, no need to do that. So root gm by r, so this will be equal to 2 pi r upon root gm into root r, right? So this will be your time period, basically. Nothing to worry about here, nothing sinister is going on. So this will be your time period. So I believe if we apply square to both sides, if we square both sides, then what will we get? T square is equal to 4 pi square r cube upon gm. This is a constant, this is r cube, this is t square. So what do we get from here? T square is proportional to r cube. Now what is this? I believe you might have seen this somewhere. You might have seen this in Kepler's third law. I'm not going to explain Kepler's law today, but this is a small vision for what is going to happen in upcoming classes. Then this thing will be called Kepler's third law. Where is eraser? Yeah, so this thing will be known as Kepler's third law. Now this is a very important law, to be honest, because it will give you the answer straight away. So we of course derived it, and from derivation we have reached towards t square is proportional to r cube, and by the way, this thing is called Kepler's third law. Now we know Kepler's third law, and now we know the derivation of Kepler's third law. We do not need to worry about that. One thing off our mind, right? So this is our time period of the satellite. Now let's move on further and let's talk about our last topic before we move towards some examples, right? Because the examples are necessary, because they will give you an insight about what's going to happen. I always say that theory should be I mean, if you're spending your time, then you should spend around 30 to 35% time on theory, and 60 to 70%, say 65 to 70% time on your basically numericals, because numericals will help you understand what the concepts are and how do you apply them and how are they applicable in real life scenarios. So that's why I say that spend time on numericals, because they will help you more than anything else. Okay, let's go towards geostationary satellites, shall we? So what do you mean by geostationary satellites? So basically geostationary satellite is nothing. It is something like this. If you see an object from Earth, suppose you're in Delhi and you see an object that is standing above you, like that, if you see a satellite that is above you, and it is above you all the time, right? So what will be the time period of satellite? Basically, what will be the time period of satellite? The time period of the satellite will be 24 hours. Why? Because Earth will rotate. Suppose this is Earth, this is axis of Earth, right? This is the center of the Earth, and Earth is rotating around this axis, right? And this is the satellite. This is the satellite. Suppose the Earth is rotating, this satellite can be seen by this face only, right? Now the Earth has rotated somewhat, and this face has has transported itself towards here. Now this can only be seen by the satellites can still be seen by this face. Again, we do that, it can be seen by this face. So basically the satellite can be seen by this face only, and it can be seen by this face all the time, right? Okay, let's get the eraser. It can be seen there by the satellite all the time. So sorry, it's an ellipse, but yeah, satellites work in ellipse, don't worry about that. So if this thing if this thing revolves around a certain point, that means this will be available to this object the entire day. So tell me, when does this point on Earth come back to its previous position? After 24 hours. So time period of the satellite, basically time period is equal to 24 hours. So that is what we mean by geostationary satellites. That means they will look stationary to you, they would look stationary to a person on ground, but they are not stationary. Of course they are moving, but their movement, their time period of their movement is 24 hours. So they look as if they are stationary in the sky. That means they are always up, they are never moving around. So that's what happens when you move with same speed, basically. Right. This can also be explained by some other thing. So basically their omega is same, right? I should not dive into this, but I'm gonna tell you this for 2 minutes. That means their omega, suppose omega is the rotation for the earth, right? Omega e, omega, and this is the rotation, of course, what is angular velocity? Yeah, omega is the e is the angular velocity of the earth, and this is the angular velocity of the satellite. Suppose this thing is circle, not ellipse, then the omega s, right? So omega e shall be equal to omega s. This thing will not come in the exam, don't worry, but this is very necessary to understand what is happening. I mean, they have the similar angular velocity. That is what's happening. So basically v by r, of course, equal to v by r, right? That's what happens. So this is a thing which you can keep in mind, but this will give you a better clarity on about what is happening, right? This is it, nothing of use here, because we're gonna find everything on our own. So let's not worry about this, but this is very interesting thing to note about if you are very interested in geostationary satellites. I mean, if you wanna look into it further, then that would help. So let's move on to the next thing. So if the time period is 24 hours, that means t square equals, of course, 4 pi square by gm r cube shall be equal to 24 hours, right? Shall be equal to, I mean, t is 24 hours, then this thing shall be equal to, you can find out the value of r, of course. Yeah, t square gm upon 4 pi square under cube root this. So basically this will be the radius of a geostationary satellite. That means that's how that it should be that far away to become geostationary satellite, and it should have a time period of 24 hours. And you can put the equation here, because 24 hours will be equal to 24 into 60 minutes into 60 seconds, because we are always talking in seconds. We use MKS system, right? So 60 into 24, basically I believe there are around 86,000 seconds in a day, so you can solve it by that. But it is never asked in the exam to solve the actual equation. Basically they will ask you, PE, is that class 11th? Yeah, that is class 11th. I was telling you about what happens. Hi Divyam, hello, welcome to the class. I was telling you about basically what happens with geostationary satellite. They are an interesting topic. So let me just give you a geostationary satellite radius. Let me give you the radius of that. Yeah, height. Let me drink some water. So yeah, the height of a, just a minute. So the height of the geostationary satellite comes out to be 35,786 kilometers. So yeah, you can note that down, by the way, if you want, but this is a trivial fact. Okay, so just note that down. If you want to remember it, go ahead, right? Nothing will stop you, but it's like a trivial fact. So they will mostly ask you question, what will happen to geostationary satellites if the radius is doubled, if the whatever. I mean, if the radius is doubled, basically, yeah, that will be the only question. Or if the time period is has been made small, or if the size of Earth decreases, increases, whatever. So basically, they will manipulate mass, they will manipulate time, they will manipulate radius, because pi square is constant, g is constant. Only these three things. By the way, this is also constant, but this can be manipulated by the question. So this can be manipulated, and this can be manipulated, and of course this can be manipulated. So basically we have at most three variables, at most three variables, right? At least zero, at least zero. That means you can also work without variable, because you have everything at your disposal. Time is will be 24 hours. There will be no, I mean, a day will be only 24 hours. Do you conduct class 12th classes? Yes, I will conduct class 12th classes, but that will be in order, I believe. Gravitation is the topic which is going on at the current time in current curriculum of class 11. That's why I'm teaching that. I will conduct class 12th classes. I have no problem with that. So that means, so basically what I'm saying, that this thing is very interesting, but this will come exam. And that's it about geostationary satellite, I believe. So by the way, there are free classes regularly, so please do subscribe us on YouTube if you want free content, and if you want to stick around with us. And next thing, let's move on towards examples. All right, examples, the most interesting part and important part about the topic, that is example. Again, a geostationary satellite orbits around the Earth in a circular orbit of radius 36,000 kilometer. Of course, that is around nearly to what I've told you, 35,786, nearly 36,000 kilometer. Then the time period of a spy satellite orbiting a few hundred kilometers above the Earth's surface will approximately be. So basically they are saying that t square is proportional to r cube, right? They want us to use that. So t1 upon t2 shall be equal to r1 upon r2, right? So one great thing about proportionality sign is that if you divide these things which are in proportion to each other, then they will become equal, as the constants will cancel, right? And because t2 and let me remove that, because t1 and t2 and t1 and t2 will have similar constants. I mean, same constant, not even similar, same constants. So that's why you cancel them. T1 by T2 square equal to R1 by R2 square. Suppose we have T1, that is 24 hours, right? So 24 hours, 24 square upon T2 square shall be somewhat equal to 6,400 upon not this, because we have chosen 24 to be above T1. R1 will be 36,000 upon 6,400. So we have to find approximately what will it be. Pretty interesting thing. Suppose approximately, right? Suppose we consider this to be 6,000. Suppose I mean, I'm doing a shortcut, and I'm also teaching you how to do shortcut. Suppose 6400, suppose this is the first assumption, and this can be wrong if the answer does not come in whole numericals, but I am thinking that it will come in whole numericals. Suppose it is equal to, because it is said that approximately, that means we need to take approximations. No worries about that. Suppose this is equal to 6,000, 6,400 equal to 6,000, right? T square equal to r cube. That means this will be equal to 36,000 upon 6,000, basically 6, right? 6 cube shall be equal to 24 square equal t square, basically 6 cube t square. Huh. So will be. Let's move on. 24, 24, 24, 24, 24, 24, 24 upon 6 into 6 into 24, 6 into 6 into 6. That will be 4 into 4. So 16 by 6, somewhat equal to somewhat equal to 16 by 6, and this will be t square. So suppose if we take t's root, suppose we take the root of this, then this will come out to be 4 by root 6, right? So what is root 6? I believe root 6 should be somewhat equal to 2.3 or 2.2, right? 2.3 basically, if I'm not wrong. 2.4 or 2.3, and suppose if it is 2.4, then this thing will approximately come out to be 4 by 2.4, approximately come out to be 2 hours. That will be our answer, and that is a correct assumption, by the way. If you try to solve it, then the answer will be nearly the same, right? Sorry, I took pick up the mic because that was I wanted to speak to you louder, because that question speaks volume in itself, right? Again, second question: a satellite is moving with a constant speed v in a circular orbit about the Earth. So it is moving at a constant speed v in a circular orbit about the Earth, and let's visualize it. Visualize what's happening about the Earth. An object of mass m is ejected from the satellite such that it escapes from the gravitational pull of the Earth. Okay. So amazing thing is happening. Imagine this. This is the Earth. A satellite is revolving around it, right? At some point it ejects an object of mass m, right? Mass m. So you just need to visualize it. Suppose it ejects an object, that means it throws an object away of mass m, of mass what? An object of mass m is ejected from the satellite, right? Okay, it is ejected from the satellite. So what is happening? Okay, let me write down m in a better way, because that was not even understandable to me. It ejects an object of mass m. A satellite is moving at v in a circular orbit. So if it is moving at v, then root gm by r shall be equal to r. R is the distance of the center of the Earth. R is the distance of the center of the Earth from the object, right? Small r. Let me just make this in a better way, because we need to understand everything. Gm by r shall be equal to v. Gm by r shall be equal to v, and this object escapes, right? That means it has escape velocity. So what is escape velocity? Escape velocity is, again, why it is capital R, it should be small r. Escape velocity is 2gm by small r. That will be your escape velocity, right? So we can say that if we divide it, then what will happen? That means ve upon v shall be equal to root 2, right? That means ve shall be equal to root 2v. Again, interesting observation. Sorry, it is little bit slanted, right? But yeah, if ve shall be equal to root 2v, why don't I write it in a better way? ve shall be equal to root 2v. Now what do we have to find? At the time of ejection, the kinetic energy of the object is calculated by your half mv square. Ke equals half mv square. At the time of ejection, it has a velocity of escape. that will be VE square. VE square. So that will be half m root 2 V square. So that will be equal to m into m by 2 into 2 V square. That will be cancel out, and it will come out to be m V square. That's how you solve a simple problem. Now I would advise you to solve as many as you can so that you can gain an understanding about what is happening. And this is your topic basically. This is gravitation lesson 2, and I believe this is it for today's class. So again, we love you and we'll see you soon in our next class. So before I go, I will give you 1 minute, see if there is anyone, and if you want to ask me anything, then that's great. If not, then that's also good. That means you understood everything. And I will, and then I will leave. So I'm giving you 1 minute to ask me anything. So a little bit advice about what is necessary to crack JEE. So basically, you need to understand that as much practice as you can perform, as much practice as you can do will be the only thing, will be a deciding factor in what will make or break JEE, nothing else. So basically that's it. So just practice more, read more theory and do more numericals. Do even more numericals if you think you have done enough numericals. There's nothing wrong with that. If you want to study, then study basically. If you can, then study 10 hours a day. That will help to crack the JEE Advanced. Basically that's it for us in today's class. I will let you go now so have a nice day. This was gravity lesson 2. I'll see you in the next class. Goodbye.